All right, this page is all about probability distributions, and remember that a probability distribution is going to be a table where you've got all of your numeric data or your numeric values for your x, and then all those probabilities of those x's occurring. So that's what we're looking at right here. What's really nice is we can use this table and we can actually calculate probabilities and solve many problems based on those probabilities, and that's exactly what we're going to do here. So we go down to the first option here. The first question is going to be asking about, in the situation above, what does P of x mean? And in this case, P of x is really just, it's standing for the probability of, so P of x is the probability of, and then defining what x is in terms of this problem, of x number of orders, per week. That's all it is. It's just determining that P of x is calculating the probability of that number of orders. All right, it's simple, straightforward. All right, next question is asking for the number of orders that has the highest probability. And all this is asking you to do is basically, can you understand what's going on in this table? We're looking for the highest probability. It looks like that's going to be this value right here, and that's corresponding to my value of 45. So sure enough, number of orders that has the highest probability is going to be where x equals 45. Straightforward stuff, right? All right, awesome. So continuing on, let's continue to scroll down. Let's see, what's the probability of getting at least 44 orders? I like these two problems. Let me back out a little bit so we can see all of this. Yeah, at least. So as I'm reading this, I realize that there's a small little typo, and not really that small. It's actually a big problem. Instead of it saying at least, what I wanted this to say was no more than 44. So no more than 44 orders. And why I wanted that is that I wanted that all of the ones in this problem, let's say C here, I'll do C with this red pen. So C, all the ones that count for C would be anything 44 or below. So all of these would count for C. And I want to know the probability of all of those when you add them together. And sure enough, when you add this together, 13, 17, that's 30, it's going to be 0.45. So when you add those red probabilities together, you get 0.45. So there's a 45% chance that you'll get a 44 or lower number of orders per week. Now, continuing on, the probability of getting 45 or more, that's going to be a little bit different. 45 or more, that one is typed in correctly. And in this case, I'm looking at 45 or more. So I'm looking at all of these last four probabilities. And when you add those together, you get 0.55. And that's what I was looking for, was that one option would be 0.44, the other one would be 0.55. So this is the probability of 4.5. This is the probability of 5.5. Now, going back to the next problem is going to take me to, if done correctly, 9C and 9D should sum to 1. Why does this happen? So I apologize if there was a typo there, but now that we've got that fixed, it makes much more sense, because 9C and 9D are complements. So 9C and 9D are complements. And once you've got those complements set up, then you know that the probability of one plus the probability of the other add up to everything. Going back to our problems, let's keep going. What is the expected value? Remember, when you see expected value, you should be thinking alarm bells should be going off in your head. You should remember what that means. That means the mean, or mu. So we know that. And in all probability functions, we can use little shortcuts. In this case, our shortcut, if this was a binomial probability, we could use the formula for binomial, but this is not binomial. We don't know if this is binomial, and it's not telling us it's binomial, so we cannot assume that. There's nothing up here. There's not a probability of a success or a failure. So we cannot assume probability, and we cannot assume binomial, so we've got to think of another way to solve this. And the other way to solve this is to put this into the calculator. To remind you how to put this into the calculator, you're going to make one list for your values of x. So this is going to be my list 1. Then I'm going to get my list 2. And then I'm going to run one variable statistic with both of those lists inside the calculator. When I do that, I've gotten a value of, my little x bar is going to give me a calculation of, it's going to give me 44.61. So the expected value over the long term of this is going to be 44.61. So overall, if I did this experiment several times, I'd get on average 44.61 as my value. Now the next question is going to ask me about if the outcome of 41 is unusual. And I give you three little hints here. And those three little hints should be part of your vocabulary when you hear unusual. Now the only problem here is this is asking about utilizing standard deviation. And we haven't calculated standard deviation yet. But on our calculator, we've got that for us. Remember, one variable stats. And we can get the calculator to calculate that for us. We've got two values. We've got our x bar, or our expected value, or our mu, and we get that to be 44.61. And we've got our standard deviation. In this case, our standard deviation is 1.73. We're looking for the value of 41. If that's going to be unusual, it's going to be on the small end. So I'm going to look at the minimum rule of thumb, the minimum value for rule of thumb. So mu minus 2 standard deviations. And in this case, that's going to be 44.61 minus 2 times 1.73. I end up getting a value of 41.15. So again, this is the minimum threshold for unusual. So if it's below this, anything outside the mu minus 2 and mu plus 2 standard deviations, then you are going to be unusual. So anything below, it looks like I got a decimal place in the wrong spot. Let me fix that really quickly. This is not 4.15. This is 41.5. Sorry about that. So 41.5. So anything out below that is going to be unusual. And in this case, my value of 41 is below that. So it is going to be yes. This is going to be unusual. Unusual.